Hey everyone, welcome back to AP Precalc. Today we're going to be going over the Unit 3A exam review. Let's get right into it. All right, so question number 1, given that g of x is a periodic function, what is the least possible value of the period of g? So here what we want to do is we really want to identify a key characteristic about the graph. So looking at this graph, I see a sharp turn right there at when x is -3, and I see it happen again for the first time right there when x is 6. So we kind of start our period at -3, and then we end our period at 6. This is going to have a distance of 9. So 9 should be our period in this case here. Question number 2, f is periodic with a period of 10. Values of f are shown in the table. For what value does f of x equal 6? So this is not talking about when -6 is our x value. It's talking about when -6 is our y value. Remember, f of x is the same thing as y in like an xy table. So here we want to see what value of x makes y equal to -6. Well, I see y equals -6, or f of x equals -6 when x is 12, right? So when x is 12, then we know y equals -6. And taking a look at our answer choices, that would be great if we saw 12 there as one of the options. It'd be very, very easy. But we don't have that. We have values from 32 all the way up to 35. However, we do know this graph is periodic with a period of 10. So what we can do is if you go one period to the right, when x is 22, when we add 10 to 12, we also know y will still be -6. The y value should be the same over equal length periods. If we continue this and we add another 10, then when x is 32, then y should become -6 as well. So that is going to be our answer, A, when x is 32. All right, question number 3. The table gives characteristics of a trig function for selected values of theta. Which of the following could define f of theta? And so here we know whatever trig function this is, whether this is sine, cosine, or even tangent. Here, when it's from pi over 2, which is right here, to pi, this trig function is positive. So this is positive here. And when we're going from 3 pi over 2 to 2 pi, this trig function is negative. So we basically are asking what trig function is going to be positive in the second quadrant, right? So quadrant 1, 2, 3, and 4. And what function is going to be negative in the fourth quadrant. And so if we remember our mnemonic device, all students take calculus, only sine is positive in the second quadrant, and it is negative in the fourth quadrant because that's where only cosine is positive. So here our answer should be B, sine only, because that fits both descriptions there. All right, number 4. The figure shows a circle centered at the origin with theta in standard position. Make sure you know that theta is going this whole angle right here because it's shaded up until that line with Q. So that is theta. Point P has kind of no relevance for us. We do know, though, the coordinates of point P are 4, 3. So let's label that to maybe help us there. So 4 and 3. And then the radius of the circle is 5. So this is going to be 5. This will also be 5. And that's going to be more important. If this is 4, 3, Q is reflected. So here, this should be -4 and then +3 there. So that is really what we're going to focus on. And now that we know our x and y values and our radius, what triangle will we extract to do SOHCAHTOA on? And a lot of people on the last quiz said this triangle right here, which is wrong. No, don't do that. So big red X there. The triangle we're actually going to want to extract is going to be that one right there. So let me enlarge it or draw it kind of off to the side. And that's because one side always has to be on the x-axis. Let's label it now. So this is -4. This is +3, and then our radius is still 5. Our radius, remember, will always be positive. And now we're just going to do SOHCAHTOA on this triangle, with this being theta, to find cosine, sine, and tangent. So cosine is adjacent over hypotenuse. The adjacent side is -4 over the hypotenuse of 5. So that should be our answer for the first part. Notice how it's negative because cosine is negative in the second quadrant as well. So only sine should be positive here. Sine is opposite over hypotenuse. And for this triangle here, our opposite side is 3 over 5, both of which are positive. So their sine is positive, so that makes sense. And then tangent is going to be opposite over adjacent. Our opposite side is 3 over -4. So -3/4 is going to be our value for tangent there, right? Question number 5, the figure shows a circle centered at the origin with theta in standard position. So here we know theta does not go to line P, it goes to this line. It's talking about this angle right there in standard position. Here we know that P is x comma y, and then S is the reflection over the x-axis, so it's going to be still x, but a negative y. Which of the following is true about sine of P? So first, let's extract our triangle to do SOHCAHTOA on. So having that, let's extract the triangle, which is going to have one side with the x-axis, so right there, one side as the radius, and then the third side is the side that makes the right angle. So let me draw that triangle maybe a little bit larger. There we go. We have theta here, we have a right angle, and then we know our radius in this case is 5. That is given to us by this point right here always. And then we know our coordinates are going to be x and then -y because it is going down instead of going up like point P is. Right, knowing this, now we just got to find sine. So sine of theta is equal to opposite over hypotenuse. So that is going to be the opposite side is -y over the hypotenuse is given to be 5. So that should be our answer in terms of x and y. That matches up with answer choice C. Let's see, so just with that you can get C, and you should be able to do the same on the test. But let's look at the definition to make sure it aligns as well. So here, if we kind of erase all this, sine of theta is going to be equal to -y over 5 because it is the ratio of the vertical displacement of of S from the x-axis. That's going to be -y. So the vertical distance or displacement from S to the x-axis, that is our -y there. And then 5 right here, let me use maybe a different color for that. So here, that was -y, and then 5 is the distance between the origin and S. That's going to be our radius, is just the distance between those 2 points there. And so it's just the ratio of those two, -y over 5, and that is aligning with the definition. So be careful. There is a chance you may just see definitions on the quiz, so just be on the lookout for that. All right, number 6, consider a circle centered at the origin in the xy plane. Let's maybe draw that. An angle that measures pi over 2 radians in standard position. So we know that's 90 degrees, so that angle has a terminal ray that intersects a circle at point P. So what's that going to look like? That's going to be like this, and then intersects a circle at point P. The angle is subtended by an arc of the circle in quadrant 1 with length 3 pi units. So taking a look here, that arc length is going to be 3 pi units. What is the radius of the circle? So here what we want to do is remember our radian angle measure formula. So radian is going to be equal to arc length over radius. And so our radian angle measure is pi over 2 radians. So pi over 2 is equal to our arc length, which is given to be 3 pi. And then we're asked to find our radius, so just solving the equation for that question mark there. And so I'm going to cross multiply here. So pi times question mark equals 3 pi times 2. This is pi times question mark equals 6 pi. Divide both sides by pi, and you get the question mark or your radius to be 6 units there. So that should be our answer for number 6. All right, question number 7. The function h is given by h of x equals sine x. And then k is a horizontal translation of h by negative pi units. Which of the following defines k in terms of h? So remember, any horizontal translation, because it's horizontal, it's going to appear on the inside of the function, so on the inside of the parentheses. So we can eliminate c and d. C and D would be if it was a vertical translation. And then because it's translation, it should be added or subtracted, so that won't help us eliminate anything. And it's typically going to be k of x equals h of x, and then minus whatever translation this is here. Let me redraw that. Whatever translation that is there. So minus negative pi units, which is going to be k of x equals h of x plus pi units. You don't even really need the units part. So A is going to be our correct answer. So remember, because you're moving it negative pi units to the right, which is basically moving it left pi units, that's going to look like A, where it's going to appear as the opposite of what it actually does. So A is the correct answer for number 7. All right, so for number 8 here, the terminal ray of the angle in standard position intersects the unit circle at point P. So that's just saying we're going to have point P on the unit circle. Which of the following is true about the sine of an angle, so the sine value, as the angle measure increases from pi over 2 to 3 pi over 2? So let's think about this logically, right? If we have this unit circle, we are starting at pi over 2, which is 90 degrees, and we are ending at 3 pi over 2, which is 270 degrees. What that is going to look like is we are starting right here on the unit circle and then making our way along the circle down as we go and approach there. And we are asked about what happens to the sine of the angle. So looking at our answer choices, does it just decrease, does it just increase, or does it do one and then the other? And so taking a look, remembering that on the unit circle, any xy coordinate is going to be, if we put it in terms of cosine and sine, it's going to be cosine theta comma sine theta. So we're really, when we're asking about the sine of an angle, we're asking about the y-coordinate. What is happening to the y-coordinate as we go from pi over 2 to 3 pi over 2? So looking at that, our y-coordinate, we are starting at a y-coordinate of positive 1, and we're going to end at a y-coordinate of negative 1. So let's see how it changes, right? Well, we're going down, and we keep going down, right? We don't change, we don't all of a sudden go up. We're constantly decreasing our y-coordinate, so the sine of the angle should decrease only, making D the correct answer for number 8. All right, number 9, the figure shows the graph of a trig function k, which of the following could be an expression. So taking a look, the first thing I want to look at is the amplitude and the midline. So I see the midline here is at negative 1. However, all of these functions have negative 1, so that will not help us eliminate any. The amplitude should be 2 here. This is 2 units. Unfortunately, I see either a positive or a negative 2. Remember, you could have negative amplitudes, so that won't help us either. So now we kind of got to look at our sine and cosine starting points, and that's really going to be the key to answering this question. So taking a look at A, here there's no horizontal translation, so we are going to start at the midline because it's a sine function. So remember, a sine function starts at the midline and goes up, and then a cosine starting point starts at the maximum and goes down. Now, unfortunately, if there's a negative sign like there is in B, C, and D, then it's the opposite. So this is with a positive a value. With a negative a value, a sine starting point is going to start at the midline and go down. and a cosine starting point is going to start at the minimum and go up. It's just going to be how it works. So looking at A, let's plot each of these graphs and see if the starting point aligns with the starting point on this graph. So here we see a positive sign, so you should be starting at the midline at 0, which is at -1 here, and then you should be going up, which is not what is happening, so A is incorrect. So that was our A sign starting point, was it in red, and that does not align, so A is not right. Let's take a look at B. Let's do this one in green. Here we are starting negative pi is going to be our uh, or pi units should be our horizontal translation. So we're starting pi units to the right, not to the left. And then it is a negative sign, so we're starting at the midline and going down. This does not align, so B is also out of it. Let's take a look at C. We'll do this one in blue. Here it's plus pi, so that should be pi units to the left, not the right. And then it's a negative sign as well, so this is going to be going down from the midline. That does not align, so it is not C. And then D here, this is 2 pi units to the left, so that's going to be right here. And it's also a negative sign, so this is going to be going down. This actually does align with the graph, so D should be our correct answer there. All right, number 10. Which of the following best describes how the rate of change is changing from pi to 3 pi over 2? Well, let's take a look at this line here. This line is part of a concave down function, and so the rate of change, because it's concave down from less than 1.1, the rate of change should be decreasing. So taking a look at our answer choices, the rate of change is decreasing, so we can eliminate A and C. Because the graph is concave down, so D is the correct answer there. All right, number 11, the graph shows, or the figure shows the graph of a sinusoidal function g. What is the amplitude and period? So here, the first thing I'm going to do is look at the max, which is at 3, and the minimums at -1. So this distance here is 4, making our amplitude half of that, which is going to be 2. So our amplitude equals 2. We can also see this by drawing our midline and then just counting the number of spaces. So here, 1, 2, 3. So this is a distance of 2 from the maximum to the midline, or from the minimum to the midline as well. Now, what is the period? Here, I would say look at a starting point. So I see a starting point right at 0. We go down, come back up at pi over 2. So that should be our period there. So our period in this case is going to be pi over 2. All right, number 12, the figure or the function g is shown by g of theta equals a times cosine b theta. If g has a period of 4 pi and an amplitude of 14, what are the values of a and b? Well, remember, a is just going to be your amplitude, so this is just going to be 14, so we can eliminate a and b right now, nothing more that we need to do from that. And then our period is 4 pi, but that is not what b should be. So b should be our b value, and remember our b value is going to be 2 pi over our period. So in this case, 2 pi over 4 pi should simplify to 1/2. So C is the correct answer there. All right, number 13. The function k can be written as a sine of theta plus d. What are the values of constants a and d? So taking a look here, I can easily draw my midline to start with, and we just want to find the amplitude and the midline. We don't need to worry about any vertical or any horizontal translations. Obviously, there is going to be vertical translations. So here, our A is our amplitude, and our D is going to be our midline. Our midline, as we see, is at 2. So I'm going to just fill that in right now. And then our A value is going to be the distance from 6 to 2, which is 4. So our A value should be 4 here and that should be how we would get 13. 14 here, this is a story problem that you can solve without a calculator just by looking at it and sketching the general graph. So here, based on this model, which of the following is true? Taking a look at this, I see an amplitude of 2.1 is your A value, and then I see a D value of 2.6. So if you kind of sketch this, which is what I would recommend, here your midline is going to be 2.6, and then going 2.1 above, our max should be 4.7, and our min should be 0.5. Let's take a look at some of our option choices and see which one is true. The maximum height is at 4.7. That is true, so we can just end there. But let's work through the rest of these. The minimum height is 2.6. That's wrong. And then here we see a horizontal translation of 1 unit to the right. So typically we would start our sine function at 0. However, we're going to now start our sine function at 1. So we're going to move it 1 unit over to the right, start right there at the midline, and go up because it's a positive sign. So that is what the graph should look like, and then you can continue it back there. But at time t equals 1, it is at the midline because it's a sine function. So it is not at the maximum and it is not at the minimum, making A still the correct answer for number 14. Number 15, here we have a minimum and a maximum value on the graph. What are the values for A and D? So let's find that. So here, if we kind of sketch a rough graph, we have 0, -5. Let me plot and label that now. And then we also have pi, 15. So let's label that as well. And then that is going to be our min and our max. So here we're going to have our maximum at 15, our minimum at -5, and then where's our midline going to be? Well, I know this distance between 5 or 15 and -5 has a distance or width of 20. And then half of that is 10. So going 10 units down from 15, we should have +5 as our midline. So D should be +5, so we can instantly eliminate A and B. Looking at this, our amplitude is going to be the distance from our midline to our maximum, which is 10. So C is the correct answer there. 16 here, the function f is given by 1 minus 2 cosine theta. Which of the following is the graph? So here I see a midline at 1. So let's sketch the midlines for all of these. And instantly I see D does not have a midline at 1. Instead, it has a midline at -1, making D the incorrect answer. So we can eliminate D, and then let's keep using process of elimination. Well, here we have an amplitude of 2, right? This is 2, this is 2, this is 2. So that really doesn't help us. But it's a -2 cosine starting point. So remember, a negative cosine starting point is going to start at the minimum and go up. And with no horizontal translation, it's just going to do that at 0. So at 0 should start at the minimum and go up. This aligns with option choice C in this case. All right, number 17, a game show uses a large spinner with a radius of 15 feet. At the time t equals 0, the spinner begins to rotate. Point P is at the wheel and is at the start position. At 10 seconds, 30 rotations have been completed, and P is at the same position as it was at time 0, so 30 full rotations. We're using it to model the y coordinate. Which of the following is the appropriate model? So here we want to see how long for our period does it take to do one rotation. So that's going to be dividing both sides by 30. So here we're going to have 1/3 be our period. That many seconds is going to be one rotation. So if our period is 1/3, then our b value should be 2 pi over our period, 1/3. which is 2 pi times 3, or 6 pi, making B the correct answer because 6 pi is also our B value in that equation as well. All right, so for number 18, we are given 5 points. Let me label them now. F is 2 comma 30, G is 6 comma 20, J is 10 10, K is 14 20, and then P is 18 comma 30. So labeling our Y values as well, we have 30, 20, and 10. We want to find the values for A, B, C, and D, knowing that this is going to be a cosine equation. So let's do that. A and D are typically what I would try to tackle first because those are going to be based off of our Y values. So taking a look, D, remember, is our midline. In this case, our midline is given to us to be 20. So that's going to be our value for D. And then our A is going to be our amplitude, which is the distance from our max to our midline. This has a distance or height of 10. So A is going to be 10 here. Now B and C are a little trickier. B, remember, is your B value, which is always going to be 2 pi over your period. And so here we know 2 pi is 2 pi, but our period is going to be the distance that it takes for a cycle to repeat itself. So here from F, go down back up to P, the distance in our X values, right? So from 2 to 18, that distance is 16, or that length is 16. That's going to be our period for this question here. So 2 pi over 16. This simplifies to pi over 8, so that is going to be our B value there, pi over 8. And then C is going to be our cosine starting point. And so when we get to choose a nice easy number for C, which is always going to be the x coordinate of F or P, which is any maximum for cosine. But because it's a horizontal translation, we have to flip the sign. So instead of 2 or 18, we should have -2 or -18. Either one would be acceptable in this case. And that should be our answer there. In the case of a sine function, so the only way this question could change is if it was like A sine B parentheses T plus C, and then plus D. In this case, you would just use the opposite of your X value for K. So -14 would be your C value there. Other than that, nothing else would change. All right, question number 19. Here we have the graph of H shown above. It can be written as A cosine, and then B theta plus D. And we want to find what is A, what is B, and what is D. So taking a look here, I see a minimum at -4, and I see a maximum at 2. So looking for our midline, the distance between them is 6, right? It's 6 units apart. And so then half of that should be 3, which should be visually and algebraically found at when when y is -1. That's going to be our midline in this case. So that's going to be our d value is -1 there. And then here we kind of already even found our amplitude. It's a distance from the midline to the max or the min. So this is just going to be +3 in this case. And then our B value is how long does it take to complete a period, and then do 2 pi over your period. So here we start at 0, go down, come back up, and then you hit the maximum at pi. So our period goes from 0 to pi, so our period is pi, which means our B value should be 2 pi over your period. Those will cancel out. And we should have a B value of 2. So that should be our answer for that one there. All right, so for question number 20 here, I'm going to read through and work through this story problem as if I was solving it, and then solve the rest of the questions after I work through this. So here the figure shows a Ferris wheel rotating in a circular clockwise direction that completes one rotation every 120 seconds. And before we even go anywhere else, I can tell you what a lot of students are probably going to incorrectly do, which is divide both sides by 120. In this case, there's zero need to do that because remember, when you have or are trying to find your period, you're looking for how long does it take to complete one cycle or one rotation. In this case, it is 120 seconds, and so that should be our period. So we now know our period is going to be 120 seconds. That's going to be huge just to start with. So that's the first part there. Point B is at the top of one of the passenger carriers and does not move, or point X does not move, which is right here. At time t equals 0, point B is at its lowest position, 10 feet directly below X. So that's going to be where point B starts at time t equals 0, which is 10 feet below. So that is shown here with that negative 10. At its highest position, point B is 40 feet above X. The sinusoidal model models the height of B above X in feet as a function of time in seconds. This is important. A positive value or a positive Y value indicates that B is above X. A negative value indicates B is below X. So we could get positive and negative values here. We could go up to positive 40 and go as low as negative 10 from the numbers that we see there. We also need to remember that point B starts at the very bottom at time t equals 0. Right? So the graph is shown for H, labeled the 5 points. So here, let me write down what I remember from the last page, which is our period was generously 120 seconds. We know the maximum and the minimum is going to be negative 10 and then positive 40 there. So that's going to be huge. And then we also know at time t equals 0, point B was at the minimum, or the lowest point possible. So first, let me label our y values, right? That's what I would always take care of first is your y values. So 40, negative 10, and then the distance between these two is 50. And so just going 20 down from, or half of that, sorry, 25 down from 40, we should get 15 as our midline there. Now that we have that, let's look at our x values. So where are we even going to start in terms of starting at time t equals 0? Well, t equals 0, point B was at the lowest point possible. It was at a minimum. So this is going to require us to take this graph here and use some of our art skills to extend it a little bit. So we're going to extend it like this and create 2 new points just for more fun. Here. Now this is where we're going to start at time t equals 0, which was a minimum in the context of the story. Let's also fill in all the y coordinates as well. We can do that as now. So negative 10, 15, 15, 15, and then 40, and 40. And now we know one period is 120 seconds. So that means from here to here, this should be 120. And remember, each of these parts, 1, 2, 3, 4, is equally split into fourths there. So this should be, if we take 120, which is the whole, and divide it into fourths, it should be 30, 30, 30, and 30 seconds in between each coordinate. So here we're going to go from 0, and let's count by 30s. 30, 60, 90, and then perfect, it comes back to 120. Continue to count by 30s because the period won't change. So this should be 150, 180, and then 210, 240, and so on and so forth if they wanted to continue that. But those should be our 5 coordinates there. All right, part B, this is always going to be the same, except the only difference is this could be h of t equals a sine b t plus c plus d. That's the only difference from this question to your exam. It could be either one of the two. So any one is fair game, either one is fair game. Here the function h can be written in that form. Let's not worry about sine right now. We are only strictly worried about cosine because that's what the question asks. Find the values for a, b, c, and d. I have the same coordinates that we just plotted right there, just for reference. So in this case, A is going to be our amplitude. We know our values are 40, 15, and then negative 10. So our distance from 40 to 15 is 25. That is our A value. Our D is our midline, so we can also knock that out pretty easy. That should just be 15. Our B value is going to be our period. And so we identified earlier our period was 120. And we see because we go from 60 all the way to 180, and that's one full cycle. So then our B value should be 2 pi over your period, which is 120 seconds. This will simplify down to pi over 60. So that's going to be our B value there. And then C, this is going to be a cosine starting point. And so what you're going to want to do is you're going to want to find one of the maximums, either F or P. You're going to want to take that X coordinate of those maximums, which is going to be either 180 or 60, and then flip it. So in this case, we'll just go 60. So 60, but then you're going to add a negative sign because it's a horizontal translation. So that should be our answer for part B. All right, so part C, we are looking from coordinate K to coordinate P. So that's going to be this portion of the graph here. If I remember the coordinates correctly, it should be 150, 15, and then 180, 40. On the interval from T1 to T2, which of the following is true? This question will always be the same, just different maybe parts of the graph. But because our y values are positive, h, the function itself, should be positive. So we can eliminate c and d just from that. And then this function is going up. It's rising as you go to the right. So this should be increasing. So A is the correct answer for CI. The next one, C2, determine the concavity of H and determine whether the rate of change of H is increasing or decreasing. So in this case, you just want to say two things. Well, looking at this, we know it's concave down because it has a downwards U shape. And so all you really need to write is concave down. And then you can add on somewhere on the page, say, I would say something more specific than just saying increasing or just decreasing. Concave down and the rate of change of H is decreasing. All right, and that's enough to get full parts. Honestly, if you just even put concave down and decreasing, last year AP accepted that too. Make sure you have both of these parts though, because if you miss one, you won't get any credit for that question. So I would hate for you to miss points for stuff that's so silly. But if you have any questions, please come see me in office hours. There'll be hopefully a review session, and then I will see you guys later. Thanks.